Hello guys, I'm back looking at the John Deere 6920S. At the end of the last video I kind of accepted defeat with my original plan, so I'm going to dismantle this model and I'm going to take the servos apart and replace the electronics inside the servo with the electronics from these two cheap hobby servos, and then we'll see how they work. We should be able to replace the electronics and then just test them to see if it's going to work at all. If it doesn't work, I'll come up with a different plan. If it does, this is what we're going to go with for this design. So we're back to square one again with this tractor. Here it is, all taken apart all over again. So what I'll need to do is tidy up these two servos, remove the wires. I'm not going to need them anymore, and then I'll take apart one of these servos and explain to you how we're going to reconnect them. Okay, here's our two servos stripped down. So let's take a look at our hobby grade servo. Only two screws holding this together. Take off the back cover, and that just exposes our little control board. So I think I've explained how a servo works, but I'll do it again anyway. This is the little motor that drives our gearbox here, and on the output shaft of our gearbox we have our little servo arm. The shaft that final gear is on comes all the way back through here to a potentiometer. That's this. This is a variable resistor that changes its resistance as the angle of the servo output changes. That is wired in such a way that it forms a voltage divider. So as the shaft inside the potentiometer rotates, it changes the resistance, and that changes the voltage on the third pin, because a voltage divider is basically two resistors connected in series between ground, and as you vary the resistors, the point between the two resistors, that voltage changes. So that's how this works. So then on this board you have a little microcontroller. You send a little pulse code modulated signal, so just a little pulse, and depending on the width of that pulse, this little microchip will then either turn the motor to rotate clockwise or counterclockwise to move the output shaft, and then it reads the value, that the voltage that's changed here, and once that voltage is matching what it knows to be the voltage associated with the signal you sent, then it stops the servo. And if you try to push the servo arm, it will again move the motor on to get this potentiometer back to where it is. So it's just a little loop system, and a very cheap, very basic system, very old fashioned too. So there's no real data, it's just a little pulse. So you can see our potentiometer wires coming out here, these three white wires. So I need those three wires. Then our motor has two wires here, but I still have the wires from the motor in the Siku board, so I'll just use those two wires. So I'll desolder those wires, and I'll desolder the wires from the potentiometer, and I'll just reconnect everything and try and squeeze it in. That's the plan now. Here's the little board out of the hobby servo. So there's a few things you need to take a note of when you're switching these over. First, that the pin in the middle is the one that varies, and that's the same on the hobby or on the servo that you're transferring your controller board to. So if that's the case, you should be able to wire them up. The next thing is to make note of where these three wires are in relation to how this servo or how this potentiometer changes. So when I rotate this potentiometer clockwise, the resistance between this pin and the middle pin gets smaller, and when I rotate this potentiometer clockwise, the resistance between this pin and this pin gets smaller also. So I need to wire these three wires in the same configuration or in the same order onto this potentiometer. Then I'm going to wire the red wire and the black wire from this motor to where I removed the red and black wire from this motor controller. Now when you plug this in, you have to be really careful, because the red wire might not be the same as the red wire on this motor. Okay, so these wires could be the opposite way around, so you could have wired the motor backwards. Then the motor's going to try and go the opposite way to get to the position you've thing, the motor is going to be going the wrong direction. So if for the steering, for example, the steering will lock over and then it won't be able to push any further, but it'll be still trying to, so you might damage the gearbox. So what you need to do when you test your servo after you've wired it is to be very careful, power it on, and if you see that it's trying to go to a ridiculous position, turn it off, move it back, and then try again to see if it goes to the same position. If you're confident that the wires are backwards, all you have to do is switch the wires of the motor. Don't touch the wires of the potentiometer, leave them alone, just switch the motor wires. I'll wire this up now and we'll see if it works. This is the steering servo, so I'll do that one first. Well, would you believe it, the polarity was different on this compared to my servo, so I can demonstrate it. So I have my servo tester over here and it's connected to give a 90-degree signal. I'm going to just gently connect this to the pins and then disconnect it, but keep an eye on the blue marks on the gear there, right? It's these two marks. So here we go. So that went clockwise, okay. But if I push it back far enough, it went the other direction. So I'll show you that again. Going clockwise. Anti-clockwise. So what's happening there is the 90-degree point must be somewhere in the middle of wherever I had it set to before I connected it, and the motor, or as the microcontroller tried to get to the point that was here, because the wire was backwards, it spun the wrong direction. And if I moved past the point to the other side, it spun the other direction, because it was still trying to get back to the point in the middle. That's how you know you have the wires backwards. And I tried not to let it get to the outer limit where it would hit the limit and be stuck bouncing on the limit. Another thing I should say though, you shouldn't be pushing the gearbox like that. It's bad to run the gear backwards because you're putting a lot of pressure on the gears at the end, because it's very hard to turn the gears backwards. It's very easy for the motor to turn through all these gears to spin here. It's very hard for the gears to get the pressure going the other way to spin the motor. So you should be very careful when you're doing that. You can break your gears in your servos doing that. Okay, here's the polarity changed, and I've kind of lined up the steering. So I'll just show you our steering lock. Kind of like that, not too bad. So that seems pretty good. The little fix to the servo seems to be working fine. I should have done this from the start. There just wasn't enough space the way I was trying to do it. So it's good that I got it sorted, but pity I had to waste so much time. So I'll do this to the next servo now, and then we'll test the lifting arms. Modifying this servo is going to be exactly the same as the steering servo, so I'll just skip that straight to the just testing of this lifting arm servo. I got the lifting arm servo together. It was a little bit annoying. Not that it was any more difficult than the other servos, just that the wires were a little bit trickier to maneuver this time. But I got it together anyway. So here is our lifting arm servo working, no problem. I'll get something to lift now. We'll see how strong it is. Here's the heaviest thing I have. You can see it's too heavy for the tractor as it is anyway. So I'll hold it down and see, can we lift it? Yeah, just about able to lift that. It is ridiculously heavy though. This has got the batteries in it, so there's no need for it really to be under that kind of load. This is kind of a small tractor, so I don't know what I'd use it for. Probably, well, it'd be good for drawing bales and stuff like that. You know, something that needs nice smooth control, because we do have nice smooth control over that servo arm there. So you know, you could lift pallets, lift bales, that kind of thing. Spin around it there. Obviously, pull trailers. Wouldn't have any trouble doing that. You could put this. You know, this is like the size of the tractor. I think it's too big for this small model. I can get something more with another battery in it that's better scaled for this. Maybe pulling the baler, that'd be what this would be good for, pulling the baler, because that That wouldn't be too big for this tractor. It'd almost look normal. Most of the Siku stuff is all huge, big stuff that you'd find in continental Europe, I guess. So it's all massively scaled. This tractor is a lot closer to what you might find in Ireland than the Massey 8680 or the John Deere 9560R. I mean, those things are huge. But anyway, that's the servos fixed anyway. So we have both our lifting arm and our steering servos working now. All I'll do is wire up those so that the power lines are connected inside the body of the tractor, so that I don't have to connect them up here, and that'll minimise the amount of wiring I have coming up through here. And if I do that, then I should be able to wire the Arduino and the radio module a little bit easier in here. Should be a small bit easier to do that. So I'm going to leave this video here, and in the next video I'll get on with the wiring. Hopefully it'll only take one video to wire it all up, because it'll pretty much just be soldering the pieces where they need to go. It won't be anything too interesting or too complex to that. Well, fingers crossed it will. I mean, I had to dismantle it once already. There's possibility that I'll mess it up again, you never know. But anyway, we'll see how it goes. So if you like this video, don't forget to hit the like button or share the video, and if you have any comments or suggestions, shoot over to the forum, join in the discussion there, and that's pretty much everything. So thanks very much for watching.